All right, one more idea for section 10.8, but before we move on, just the final a plus bi form for that previous problem, 0 minus 4/5 I. Okay, there's a pattern here that I want us to look at. I is just I. Big shock there, huh? We know I squared is -1. I cubed, though, is I squared times I, which is -1 times I, or just -I. And then I to the fourth is I squared times I squared, which is -1 times -1, which is 1. I to the fifth is I to the fourth times I. Well, I to the fourth is 1, so it's just 1I. And this pattern continues. So the pattern goes, I is I squared is -1, I cubed is I fourth is 1. And then that pattern repeats. I to the fifth is I to the sixth is I to the seventh, -1, I to the seventh is I to the eighth is 1. And pick any one of these. Let's go with I to the seventh. And that's because I to the seventh is the same as I to the fourth times I to the third. Well, I to the fourth is 1. I to the third is I. So just -I. So this pattern continues on and on and on. All right, so following that pattern for I to the ninth, well, the next one in line would just be plain old I. But we can look at that as it's I to the fourth times I to the fourth times I. 4 plus 4 plus 1 is 9. So that's 1 times I, or just I. And so the number of groupings of 4 we can get is kind of important here. So the 43rd power of I, well, that is I to the fourth times I to the fourth. We're going to have how many groups of I to the fourth here? Well, if we have 10 groups of I to the fourth, right, 10 groups of that would make 40. So that would just be 1 times 1 times 1 times 1, 10 times. But we would still need 3 more of them. So it would be times I to the third. I to the third is -1. Sorry, -I. So this whole thing would just simplify to -I. And we're really just trying to figure out how many groups of I to the fourth are there, and then what's left over. There were 10 groups of I to the fourth. Those 10 groups of I to the fourth are just 1. And what's left over is I to the third, which is -I in that chart. So I to the 22nd, we're looking at, we could make 5 groups of I to the fourth. But what's left over? 5 times 4 is 20. So there's going to be an I squared left over. So those 5 groups are just 1 times 1 times 1 times 1 times 1 times 1, or the number 1. That's always going to be the way this pattern works out. And then I squared is -1. So this whole thing just simplifies to -1. And then finally, I to the 32nd. Well, we could have 8 perfect groups of 4 out of that. So I to the fourth times I to the fourth, and we're going to have 8 of those groups. All 8 of those are just 1 times 1 times 1, 8 times, which is just the number 1. And there's nothing left on the outside, so the answer is just the number 1. So again, we're really looking at how many groups of 4, but more important than that is what's left over. It's actually an application of the remainder here. So when we divide by 4, 9 divided by 4 is 2, remainder 1. And that 1 is what matters, I to the first. Divide by 4, 43 is 10, remainder 3. So what really matters there is the I to the third. And then 22 divided by 4, that would be 5, remainder 2. So again, the final answer is just going to be whatever I squared is, which is -1. And then divide by 4, remainder 0. Whenever it's remainder 0, the answer is going to be 1.